On the night of August 15, 1977, a radio telescope in Ohio recorded a signal from deep space unlike anything it had picked up before or since. It lasted 72 seconds, the maximum amount of time the telescope's fixed field of view could have tracked a single point in the sky before rotating past it, meaning the signal may well have lasted even longer than what was recorded. It arrived at almost exactly the frequency hydrogen atoms naturally emit at Angels, a frequency SETI researchers had specifically chosen to monitor, on the theory that any advanced civilization trying to get attention across the galaxy would broadcast at a wavelength every other civilization with radio astronomy would already be watching. A few days later, astronomer Jerry Amon reviewed the printout, saw the signal's intensity spike far above the background noise, and circled it in red pen. Next to it, without much thought, he wrote a single word. Wow. The name stuck. 47 years later, it's still the single most famous unexplained signal in the history of the search for extraterrestrial intelligence. Not because it was definitively alien, but because, despite everything astronomers have thrown at it since, nobody has been able to fully explain what it actually was. This is Deep Space Declassified. New classified file every week. Subscribe before we go further. Let's get into it. The WOW signal was picked up by Big Ear, a radio telescope at Ohio State University, built specifically for one purpose: scanning the sky for exactly this kind of anomaly, as part of a long-running SETI survey. Big Ear didn't point at specific targets the way a conventional telescope does. It used Earth's own rotation to sweep a fixed strip of sky, recording whatever passed through its field of view over time. That design meant a real signal from a fixed point in space should show a very specific, predictable shape, rising smoothly to a peak brightness as it entered the telescope's beam, holding near peak for a characteristic duration, then fading smoothly as Earth's rotation carried the beam away from it. The WOW signal matched that expected shape almost perfectly. It rose, peaked, and fell exactly the way a genuine signal from a fixed celestial coordinate should, which immediately ruled out most kinds of terrestrial interference, satellite transmissions, or reflected signals, none of which would be expected to follow that precise rise and fall pattern tied to Earth's rotation. Its frequency, 1420.4 MHz, sat almost exactly on the hydrogen line, the specific frequency at which neutral hydrogen atoms naturally emit radio waves as their electrons flip spin states. It's the most abundant element in the universe, emitting at a frequency every radio astronomer in the galaxy would know to listen for. That's precisely why early SETI researchers, including those running Big Ear's survey, chose to monitor that frequency in the first place, reasoning that any civilization trying to signal across interstellar distances would likely choose a frequency the physics of the universe itself makes universally obvious. The signal's location matters almost as much as its shape. It came from a specific point in the sky near the constellation Sagittarius, close to the globular cluster M55e, not from the direction of the Sun, not from a known satellite path, and not from any previously catalogued radio source strong enough to explain it. Follow-up observations began almost immediately. Astronomers pointed telescopes back at those exact coordinates repeatedly over the following decades, during the initial search in the weeks after the detection, and in dedicated follow-up campaigns for years afterward. Nothing was ever found there again. Not a fainter echo, not a weaker repeat, not the slightest trace of the signal returning. That absence became the central problem the WOW signal has posed for nearly 5 decades. A genuinely artificial signal, deliberately transmitted by an extraterrestrial source, would plausibly be expected to have some pattern, some element of repetition, especially if it was intended to attract attention. A single, unrepeated 72-second burst is exactly the kind of event that's almost impossible to fully confirm or fully rule out. There's no second data point to compare against, no spectrum to analyze in more detail, just one printout, one red circle, and one word in the margin. The first serious natural explanation came in 2016 when researcher Antonio Paris proposed that the signal came from a passing comet. Comets are surrounded by enormous clouds of hydrogen gas, sometimes stretching millions of kilometers from the nucleus, as solar radiation strips hydrogen from water ice, sublimating off the comet's surface. Paris identified two comets, 266P/Christensen and P/2008Y2 Gibbs, that, according to his calculations, would have been passing through roughly the right region of sky in 1977, even though neither comet had actually been discovered yet at the time of the original signal. The comet hypothesis was appealing because it offered a clean natural explanation and accounted for why the signal never repeated. A comet is a moving target, and by the time anyone looked again, it would have moved on. Paris conducted follow-up observations in 2016 and 2017, reporting radio emissions near the predicted frequency when pointing at one of the comets. But the hypothesis ran into a fundamental problem almost immediately, raised by the very team that had discovered the original signal in the first place. A comet's hydrogen cloud is diffuse, covering a wide area of sky. Big Ear's telescope design should have detected a much more gradual, spread-out signal from an object like that, not the sharp, cleanly bounded rise and fall shape actually recorded. Most of the SETI research community considers the comet hypothesis effectively ruled out. The most significant recent development came from an entirely different direction. Not new observations of the original signal's location, but a systematic search for similar signals elsewhere. Starting in 2017, a team led by astrobiologist Abel Méndez at the Planetary Habitability Laboratory at the University of Puerto Rico launched what they called the Arecibo WOW project, digging through archived data from the former Arecibo Observatory, one of the most sensitive radio telescopes ever built, before its collapse in 2020. Méndez had, for years, personally leaned toward dismissing the original WOW signal as some kind of instrumental glitch. That changed when his team found something unexpected in the Arecibo archive. Between February and May of 2020, the telescope had picked up multiple instances of radioactivity strikingly similar in character to the original 1977 signal, narrowband, intense, and located at positions that corresponded to known cold clouds of neutral hydrogen gas drifting in interstellar space. Finding several WOW-like signals spread across different sky locations, all associated with hydrogen clouds, pointed towards something the original 1977 search never had the data to consider. A natural astrophysical mechanism capable of making an ordinarily faint, cold hydrogen cloud suddenly flare up brightly enough to be detected, then fade back into obscurity just as quickly. The mechanism Méndez and his co-authors proposed involves a genuinely exotic combination of astrophysics, stimulated emission from cold hydrogen gas triggered by an external transient burst of powerful radiation. Cold hydrogen clouds normally emit at the 1420 MHz hydrogen line constantly, but extremely faintly, far too weak to explain a signal as intense as the original WOW detection. The team's hypothesis is that a sudden, powerful blast of radiation from a source like a magnetar flare, an extraordinarily magnetized dead star capable of releasing enormous bursts of energy, or a soft gamma repeater, a related class of object, striking a cold hydrogen cloud could trigger a process called stimulated emission, essentially forcing the cloud to release its stored energy all at once in a brief, dramatically amplified flash at the hydrogen frequency. This would explain several things at once: the extreme intensity relative to a normal, quiet hydrogen cloud, the narrow, specific frequency matching the hydrogen line, and, critically, why the signal never repeated because the triggering event, a magnetar flare passing through exactly the right location at exactly the right moment, would itself be a rare, one-time occurrence, not a property of the region of sky itself. Our results don't solve the mystery of the WOW signal, Méndez has said of the research, but they give us the clearest picture yet of what it was and where it came from. It's worth being precise about what this new research does and doesn't establish because it's easy to overstate. The team did not detect the original 1977 event happening again, and they did not find a hydrogen cloud sitting at the exact original WOW coordinates that they can prove flared in that specific way on that specific night. What they found is a broader phenomenon, multiple newer, independent examples of wow-like signals, all sharing the key characteristics of the original, all associated with cold hydrogen clouds, all detected using the same kind of instrument that recorded the original signal in 1977. That's a meaningfully different kind of evidence than a direct explanation. It establishes that a natural mechanism capable of producing wow-like signals genuinely exists and has been observed multiple times since, which makes it a strong candidate explanation for the original event without being definitive proof of what specifically happened on that one August night in Ohio, 43 years before the confirming data was even collected. The research also opened up a new, practical concern for the wider SETI field. If cold hydrogen clouds can flare this dramatically under the right conditions, that's a previously unrecognized source of false positives, meaning some future SETI detections that look promising and artificial could, in principle, turn out to be the exact same natural phenomenon. The wow signal sits at a genuinely unusual point in the history of SETI research, because unlike most claimed detections, it has never been fully debunked and never been confirmed, a status that has held, essentially unchanged, for nearly 5 decades. Compare that to the vast majority of other historical signal claims in SETI's history, most of which were identified as terrestrial interference, satellite transmissions, or instrumental artifacts within days, weeks, or at most a few years of detection. The wow signal has outlasted nearly all of them specifically because the evidence for a mundane explanation and the evidence against one have both remained genuinely ambiguous for this long. That ambiguity is exactly why it remains, even now, one of the most cited examples in any serious discussion of SETI methodology. Not because researchers think it's likely to have been an actual alien transmission, but because it illustrates precisely how difficult it is to conclusively categorize an unrepeated narrowband radio signal, even with the benefit of nearly 50 years of hindsight and improving astrophysical understanding. The continuing search has also produced something practical, a low-cost citizen science initiative called WOW at Home, launched as an outgrowth of the ongoing research into the original signal. The project allows amateur radio astronomers and enthusiasts using comparatively affordable equipment to participate in scanning for similar, rare, transient hydrogen line events, broadening the search far beyond what a handful of professional research teams could accomplish scanning archived data alone. Given that the newer wow-like signals were found by combing through years of previously collected archival data rather than through real-time monitoring, a wider network of contributing observers watching more of the sky more of the time meaningfully increases the odds of catching another event as it happens rather than finding it years later in an archive. This reflects a broader shift in how SETI research approaches ambiguous, one-off signals. Rather than treating the original wow signal as a closed cold case, researchers are now using it as the template for an active, ongoing search, treating unexplained transient radio bursts as a real astrophysical phenomenon worth systematically hunting for, whatever their ultimate origin turns out to be. So, where does that leave the actual question everyone wants answered? Was it aliens? The honest scientific answer, 47 years on, is that the balance of evidence has shifted meaningfully toward a natural explanation without fully closing the door. The magnetar-triggered hydrogen cloud hypothesis is, by most researchers' assessment, currently the strongest and best-supported natural explanation yet proposed, stronger than the Comet hypothesis it displaced, and grounded in actual repeated observations of similar events rather than pure theoretical speculation. But strongest natural explanation is not the same as confirmed explanation. No one has proven that a magnetar flare or soft gamma repeater actually struck a specific hydrogen cloud at the WOW signal's exact coordinates on that exact night in 1977. The specific event remains technically unconfirmed either way, genuinely unusual for a scientific question with this much sustained attention and this many independent research efforts directed at it. What has changed is the shape of the mystery. In 1977, the WOW signal was a genuine unknown with almost no framework for evaluating it. Today, it's an unconfirmed instance of a now documented recurring natural phenomenon, a meaningfully different and considerably less exotic kind of mystery than the one Jerry Eamon circled in red ink. 47 years ago, a radio telescope in Ohio recorded 72 seconds of an intense narrowband signal at almost exactly the frequency hydrogen emits at, arriving from a fixed point in the sky, shaped exactly the way a real astronomical signal should be shaped. It never repeated. And for decades, nobody had a solid natural explanation for what could produce something like it. That's changed, at least partially. Researchers scanning archived data from an entirely different observatory found multiple newer signals sharing the WOW signal's key characteristics, all linked to cold hydrogen clouds, all consistent with a specific testable mechanism involving a magnetar's flare striking interstellar gas and triggering a brief, brilliant flash of stimulated emission. It's the clearest picture anyone has assembled of what the WOW signal might have been. It is still not proof of what it actually was. The original 72 seconds of data, recorded on a single night in 1977, remains exactly what it's always been, one unrepeated event, from one fixed point in the sky that no one has ever been able to observe again. Do you think it was a magnetar-triggered hydrogen flare, or do you still think it was something else? Leave your theory in the comments, and subscribe, because the next classified file goes up in a week.